everyone, and welcome to today's lesson. I'm so glad that you all tuned in. So today, I cannot actually believe that it's that time of the year already, because we're talking about exam preparation, and we're talking about preparing for exam paper 1 in today's lesson. So obviously you've done so much already in the first 2 terms. We aren't going to have time to go through absolutely every section, and we've done some sections in more detail than we have others. So today I really want to concentrate on those sections that we've neglected a little bit, or that need a little bit more help. I find that a lot of learners might struggle with these specific type of questions. So all of the questions in today's lesson are going to be exam type questions. So they have been either in a past official paper or they've been in a school test, okay? And we're really going to revise these types of questions, specifically looking at sequences and series. We're also going to have a look at functions and inverses, and then we'll throw in some financial maths as well. So remember, when you get to this time of the year, when it's time to prepare for exams, the best way to prepare is to go through lots of past papers and to redo questions from your homework assignments and that kind of thing. And remember, if all you're doing is memorizing solutions, it's going to be very easy to forget what you've memorized. Maths is not a section where you can just memorize solutions and then go and fill that out onto a paper, because what happens then is, as soon as the question has a little trick or a little change in it, you can't do it because you've memorized only one way to do it. So maths is not about memorizing, not at all. What you've got to do here is you've got to understand the logic behind what you're doing, and what you've got to also do is to apply that process so many times that you're not worried about, well, am I going to get this wrong? Am I going to get this wrong? What you're always going to find is that if you've applied the process logically and correctly, and you understand the process, you're more likely to never get the question wrong and always get it right, because you understand the process. Okay, so those little changes won't throw you off. Okay, so let's go through. We're starting today's lesson by looking at some sequences and series. And as I said, all of these you will see have marks on your screen. And just to give you an indication of how much of time you should be spending on these questions. So it's really, we're working at a mark per minute. So you'll see in first question 1, you've got a total marks there of 4 minutes, 4 marks. So it shouldn't take you more than 4 minutes to do it. But what I'm going to do is I'm going to give you 2 minutes to take it down. Okay, everyone, so hopefully you had a chance to now take this down. Maybe you didn't have the whole 4 minutes to work it out, but it shouldn't take you more than 4 minutes to do a question like this. Now, one of the things that should have struck you immediately with this question, and this is why it gets a few people stumped, is that you aren't told what type of sequence it is. So you don't know, is it geometric, is it arithmetic, is it quadratic, what is it? And that sometimes gets people stumped, but you really don't need that information to do this question. So let's see how to do this. So you are told that the sum of the first n terms is given by that formula, and you are asked to firstly find the sum of the first 6 terms and then to determine the first 3 terms. So to work out the sum of the first 6 terms, it really is quite a simple one, that just for 1 mark you'll see, because all we need to do in order to work out the sum of 6 terms is we need to replace n with 6. So we're simply going to substitute the value of n, we replace it with 6. Alright, so we work this out, we're going to get 3 to the power of 5 plus 9. Okay, and let's have a quick look at what that's going to give us. So it's 3 raised to the power of 5 plus 9. And that gives us 252. So that's an easy 1 mark there. Hopefully all of you realized how to do this. It's a simple matter of substitution. Now for the next one, where we've got to work out the first 3 terms, and remember here they're saying not work out the sum of the first 3 terms. They want the actual value of the terms as they sit in the sequence. So how do we do that? Well, let's have a look at this. We know that in our sequence, well, we're saying we've got 3 terms, so we know it's going to be term 1, term 2, and term 3. And remember, they've given you a formula to work out the sum of n terms of the sequence. So we've got Sn is equal to 3 to the power n minus 1 plus 9. Now, if we are using, all we've got really to work with is Sn, we've got to now start thinking, how does Sn relate to Tn, which is your term values? Well, if you think about it, the sum of 1 terms is basically going to give you the value of the first term, and that should make sense to you because all you're doing is you're adding nothing. It's just the value of that term itself. So therefore, if I want to find the first term, I'm going to replace n with 1. So sum of 1 term, so it's going to be 3 to the power 1 minus 1 plus 9. So that's 3 to the power of 0, and anything to the power of 0 we know is 1, so it's 1 plus 9. So my first term is going to be 10. All right. Now for the next one, and here's where you've got to apply your logic. So I know that the first term is 10. And I've got a formula to work out the sum of the first 2 terms. So I can also work out the sum of the first 2 terms by saying T1 plus T2. So therefore, if I find the sum of those 2 terms, and I subtract the sum of the first term, which was in fact just the term itself, that should give me the value of term 2. Okay, so this is what we're saying. We're saying find the sum of 2 terms. So once again, you replace n with 2, so it becomes 3 to the power 2 minus 1, which is 1, plus 9. All right, and that's going to give me 12. So the sum of 2 terms is 12. Okay, and I know that the sum of the first term was 10. So therefore, term 2 is going to be sum of 2 terms minus the sum of 1 term. So it's going to be 12 minus 10, which gives me a value of 2. So therefore, term 2 itself will have a value of 2. Okay, and then to find term 3, it's exactly the same process. It's going to be term 3 is the sum of 3 terms minus the sum of 2 terms. Okay, so we first work out the sum of 3 terms. So we replace n with 3. So this becomes 3 minus 1 plus 9. So that's 3 to the power 2, which is 9, plus 9, which gives me 18. So therefore I know the sum of 3 terms is 18. I know that the sum of 2 terms, which we saw before, was 12. So therefore I can work out that term 3 is going to be S3 minus S2, which is 18 minus 12, and that gives me a value of 6. So therefore what we see is that we have a decreasing sequence, and we've got our first 3 terms as 10, 2, and 6. Hopefully all of you got to these same values as well. Let's quickly have a look at another sequences and series question, and this time I'm going to give you 2 minutes to have a look at it. Okay, everyone, so hopefully you got all of the key points down from this question. We were given a geometric sequence, and we know that in a geometric sequence, what makes it geometric is there's always a common ratio, all right? So let's have a look at the question. You were given this geometric sequence, and you were asked to find the sum to infinity minus the sum of n terms in the form a, which is a coefficient, times b to the power of n, where it should be written here, Sn is the sum of the first n terms of the sequence. So there's more than one way to do this question, and that's one of the reasons that maths is my favorite subject, because there's always more than one way to get to the same solution. Some ways are easier than others, okay? So I'm going to do a certain method. If you didn't do the same method, but you follow the correct processes and logic and you get the same answer, then you will get full marks, all right? Okay, so here we are given a geometric sequence, and we see that it's 10, 5, 2,5, 1,25. It's a decreasing geometric sequence. The first thing I want to do before I look at anything is to work out my ratio. So I'm going to say term 2 divided by term 1, and that's going to give me 5 divided by 10, which is a half. So I know what my ratio is. Hence, and I just quickly as a check for myself, because always remember, while you've read the question, keep in mind what you've been told. You're going to work out a sum to infinity. And the only way we can work out a sum to infinity is if your ratio is between 1 and minus 1. And since a half does sit between 1 and minus 1, we would be able to work out, this is a convergent sum to infinity, so we would be able to work out the sum to infinity. All right, so as I said, more than one way to do it. So how I'm going to do it is I'm going to use the formulae for sum to infinity and sum to n terms. So sum to infinity we know is a over 1 minus r. Sum to n terms is a times, and I'm going to use this one, 1 minus r to the n all over 1 minus r. All right. I'm then going to just work with those formulae. So I'm not going to substitute any values in. So I'm going to say, well, they've asked me to work out the difference between these two formulae and put it in a specific pattern. So therefore it's going to be, let's put in our formulae. So it's a over 1 minus r minus a times 1 minus r to the n all over 1 minus r. Now guys, what you'll notice, and that's why I wrote my sum to n in that way rather than r minus 1, is I have the same denominator. So because I've got the same denominator, I can simply subtract my numerators. So I get a minus a times 1 minus r to the n all over 1 minus r. And that's going to give me, so let's just simplify that. We times the minus a into the bracket, so I get a, minus times a minus is a plus, so it's plus a times r to the n all over 1 minus r. And I can see that this simplifies, a minus a cancels, so I get a times r to the n over 1 minus r, and I can't go any further with that. So now at this point I'm going to start putting in the values that we have for a and for r. So you can see what I've done is I've used the formula, simplified it to another formula where I'm going to now substitute values in. So we go back to our sequence and we see that we were given that the value of a was 10. So I put a in as 10. My ratio we worked out was a half, and that's all over 1 minus a half. So we've got 10 divided by 10 divided by a half, because 1 minus a half is a half, times a half to the power of n. Now 10 divided by a half, it's the same as saying 10 times 2 over 1. You tip and times a half to the n. So that's going to give me 20 times a half to the power of n, and it is indeed in that form that they asked for, a coefficient times some b to some exponent n. All right, okay guys, so that's how you do that one there. And as I said to you, there's more than one way to do it. Hopefully whatever method you use, you got to the same answer. All right, we're back after this. Welcome back everyone. So a reminder, in today's lesson we are having a look at exam preparation for paper 1. So far we've looked at sequences and series, and now we're going to move on to functions and inverses. As I said to you at the beginning of today's lesson, all of these questions can be found in past tests and in past papers. All right, so let's have a look at question 3 now. And this, as I said, we're looking at functions, all right, and their inverses. And this is a long one to take down. So what I'm going to do, guys, is I'm going to give you, we're going to break the question up. It is quite a long one. But I'd like you, the main thing is to take down the graph. So draw this graph and take down the given information. Okay, get down as much as you can of the first 4 questions. I'll give you more time to take down the last 2. But get down as much as you can of those questions so that when you look at it, you can go through it yourself. But we will go through the whole thing together. All right, so in total, I'm going to give you 2 minutes for the first part, and then we'll have more time to take down the rest of the question just now. Okay, everyone, so I know that this was a long one to get down. There was so much of information, but I said I am going to give you more time to take down the rest of the question. We're just in the beginning now going to look at part from 3.1 to 3.4. Okay, so let's go through the graph that you were given. Okay, you were given that you've got a function h of x, which is equal to 2x minus 3. We recognize that as a linear function. We see that it has a restricted domain where x is less than equal to 4, greater than equal to minus 2. So we've got a domain that has been restricted. We are told that the x-intercept of this straight line is at the point Q. Okay. The first part of the question, okay, let's just talk about this firstly before I move on. So you can see that your domain is only drawn from x is minus 2 on the x-axis to x is equal to 4 on the x-axis as well. So we're only interested in this section of the graph, okay? Because remember, this linear graph will carry on to infinity if we had little arrows at the end, okay? The first question says, determine the coordinates of Q, and we can see from the graph that Q is the x-intercept of h of x. And I know that to find the x-intercept, what I've got to do is I've got to say, let y equal to 0. So 3.1, to find the coordinates of Q, I know that my function h of x is equal to 2x minus 3. So to find the x-intercept, we say, let y equal 0. And we solve for x. So we're going to get 2x minus 3 is equal to 0. Therefore, x will be equal to 3 over 2, 1.5. You just get that by taking your 3 over to the right-hand side and then dividing both sides by 2. So therefore, the coordinates of 2 are going to be 1.5 and 0. Okay, so that's a relatively straightforward question. Most of you should have got the answer to that one. All right, the next one says, write down the domain, okay, and it wasn't given here. For some reason, we don't see what the rest of the question is, but write down the domain of the inverse, h inverse x. So write down the domain of the inverse of this graph. Now remember, when you're dealing with inverses, your x and your y values swap around. So if I'm looking now for the domain of the inverse graph, that means that it was the range of the original function. So the range of h of x will become the domain of the inverse graph. Okay, so therefore, since I've been given the domain of h of x, you were told it's a restricted domain where x is between minus 2 and 4. In order for me to work out the domain of the inverse graph, I need to find the range of h of x. So the range of h of x is going to be the domain of the inverse. How do I find the range? Well, I need to find what are the limiting y values. So I see the graph stops at 4 and minus 2 on the x, but what are the y values at that point? Okay, so simply what I'm going to do is I replace x with minus 2 to find the limiting point on the negative side. So I'm going to get h of minus 2 is going to be minus 2. So I'm replacing it into that function. Replacing x with minus 2, so 2 times minus 2 minus 3. So that gives me minus 4 minus 3 is minus 7. So I know that y is going to be greater than equal to minus 7 and less than equal to find that endpoint, I replace x with 4. So I say h of 4. So we're simply doing a substitution here. And we get 4 times 2 minus 3. So that gives me 8 minus 3, which gives me 5. Okay, so that means the y value at that point is 5, and the y value here at the bottom is minus 7. So therefore your range of your function h of x is between minus 7 and 5. So therefore this range is now going to be the domain of your inverse graph. So therefore for part 3.2, where they say what is the domain for h inverse x, we're going to have that x is an element, close brackets, from minus 7 to 5. All right, so that's going to be our domain for the inverse graph. Okay, so now that we've got this domain for the inverse graph, we're kind of getting a picture in our head of what this graph is going to look like, right? Hopefully you are as well. So we're dealing with a linear function, therefore the inverse of this graph is also going to be a linear function, okay, with the domain and ranges swapped around. Okay, so the next one says, sketch clearly and indicate the y-intercept and the endpoints of, again, sorry, this is missing, it should say of the inverse graph. All right, so sketch clearly and indicate the y-intercept and the endpoints of your inverse graph. So remember, when you are dealing with inverses, everything swaps around, and I'm simply going to draw our inverse graph on the same axes that we've got here, the same set of axes. Okay, so everything swaps around when you're dealing with inverses. So in my inverse graph, my y-intercept is now going to become my x-intercept. And my x-intercept of the original function, which you'll remember was 1.5, is now going to become the y-intercept. So this is going to be the point 1, 5, 0 and 1, 5. All right? So just using those 2 points, I can already draw in my straight line. Okay, so let's do that. It's going to be a straight line going through the x-intercept of minus 3 and the y-intercept of minus 0.5. Okay, and obviously if you continue this graph, these 2 lines are going to intersect as well. All right. They also said to you, show or put in the endpoints. Okay, so our endpoints here, remember we worked out that the domain went from minus 7 to 5 in our inverse function. So therefore, my endpoints, exactly like what you see you've got here on your original drawing, that's what you're going to put in, is some endpoint. So we know that the x value at the one endpoint is going to be minus 7, and the x value at the other endpoint is going to be 5. So we've restricted this graph, and we can then obviously draw across. So if I extend my x-axis there, I draw across to where the inverse graph will end. Okay, so those are the endpoints. All right, guys. So what I want to do is I want to just give you a quick moment to just take down anything that you haven't got yet on these graphs. We're going to take a quick break now before we carry on with the rest of the question, because there's still quite a bit for us to do. We'll be back after this. Welcome back, everyone. So a reminder that we are continuing with question 3, which I gave you just before this break, where we had a look at a straight line, a linear graph, h of x, and its inverse, which was also a linear graph. Okay, so I'm going to give you more time to take down the rest of this question. Let's see how far you can get with taking it down. I'm only going to give you 2 minutes. We've just got a little bit of the question left, so you're not going to have a chance to really do the question at home or if you're in school or wherever you are. But we'll go through the question together. So you're going to have the graphs there, mark down all the information that you possibly can, and then take down some of the key points that we're going to be looking at for the rest of this graph. Okay, so we've gone up to, just before the break, we got up to question 3.3. And as you can see, unfortunately, some of the equations were missing, so I've filled them in for you there in pen. So hopefully you can see all of that. And we're going to go now from question 3.4 to 3.6. So that's the little section there that you want to take down. And we'll give you 2 minutes to take it down. Okay guys, so let's go through this question. It's quite a long one, so I want to get straight into it and let's go through it together. So the 3.4 is the first one that we're doing now. For which values of x will the inverse graph be equal to the original function? Now guys, there's more than one way to do this question, as with a lot of the other questions we've looked at as well. The one way you can do it is you can work out the actual equation of the inverse graph, and then using, because we know that to find a point of intersection, we've got to use simultaneous equations. So once we've got the equation of the inverse graph, which would be quite easy to work out from this, we can then equate that to the equation of the original function and solve for x or y. The other way we can do it, and the way I'm going to do it, is we know that these graphs, inverses, will always intersect at the point y is equal to x. Now think about that. Why would they intersect at the point y is equal to x? Well, y is equal to x is your axis of symmetry, right? Remember that. So y is equal to x will be your axis of symmetry. So that will be the point where these two graphs will intersect. And obviously your line there is going to continue infinitely, the line y is equal to x. All right. So, in fact, what I'm going to do is just undo the blue line because we want a line that's going to continue infinitely. So I'm going to quickly make a sketch of our other line that we just drew on the other side, which we saw had a y-intercept of 1.5 and an x-intercept of -3, and that was our inverse graph. All right, so all of these lines, and you can't really see it because we've got to go on the page to show it, but all you will see is that these lines will actually, these two lines, h of x and h of the inverse of x, so h of x and the inverse graph, they are all going to intersect at some point where y is equal to x. So that's the point they're going to all intersect at. So if I want to find the point of intersection between these graphs, I'm simply going to say, well, it's the point where y is equal to x. So therefore, I'm going to take my equation h of x, which was 2x minus 3, and equate that to x. All right? And if we do that and solve for x, we're going to get 2x minus x is just going to give me x is equal to 3. So therefore, they are going to intersect at the point when x is equal to 3. All right, and they just wanted the x value, so that's going to happen at the point x is equal to 3. Okay, let's go straight into the next one, which says if P is the point xy and it's on the graph, it's closest to the origin, calculate the distance OP. So we're looking for the distance OP, which is that distance there. And we know, remember, the shortest distance between 2 points is always going to be a perpendicular distance. So therefore, the shortest distance here from O to P is also going to be a perpendicular distance, okay? Once again, there's more than one way to work this out, okay? What I'm going to do is I'm going to say, well, this distance OP can be worked out using the fact that P is the point x and 2x minus 3. So it's a point that lies on your graph h of x. So therefore, to find the coordinates at some x value, and if we have that x value, we'll substitute into 2x minus 3 to find the y value. So therefore, those are the coordinates of the point P. Now, if I can find the distance OP squared, which we can using the distance formula, then in order, remember what we're looking for is the minimum distance. In order to minimize the distance OP, we need to minimize we need to find the derivative of OP so we can minimize that distance, okay? So let's have a look at working out OP squared. So therefore, it's going to be using my distance formula, x minus 0 squared plus 2x minus 3 squared. So that's going to give me x squared plus 4x squared minus 12x plus 9. So that gives me 5x squared minus 12x plus 9. So that's the distance OP squared. Okay, so for OP to be at its minimum, this distance OP squared needs to be at its minimum. So, and we can see that this is a parabola function, hey? So I can find the turning point. It is one with a minimum turning point, and the easiest way to do that is to take the derivative of OP squared. Okay, so we're going to say OP squared, and we're going to take the derivative of that. So it's going to be, remember your OP squared was 5x squared minus 12x plus 9. So your derivative will be 10x minus 12. When we're looking for the minimum point, we say the derivative must be equal to 0. So we equate that to 0 and we solve for x, and we'll get 10x is equal to 12. Divide both sides by 10, so x will be 12 over 10, and we can simplify that. 2 goes into 12 6 times, 2 goes into 10 5 times. So therefore x will be 6 over 5. So that's going to be the value that will minimize this distance OP squared, and hence it will also minimize the distance OP. Okay, so now let's work out the minimum distance of OP. Okay, so what you're going to do here is you're going to need to take that value, 6 over 5, put it into your equation OP squared, and then take the square root. So OP squared is going to be, let's just substitute, it's going to be 5 times 6 over 5 squared minus 12 times 6 over 5 plus 9. Okay, if you simplify all of this on the right-hand side, you can obviously use your calculator. I've got my working out already, but if you work out all of that, you will get an answer of 9 over 5. So that's OP squared. Therefore, OP will be the square root of that distance. So it will be the square root of 9 is 3 over root 5. Or if you put that into your calculator, you can get a decimal value of 1,34 units. All right, so that's a little bit untidy. So let's just do that again. It's 1,34 units. Okay, guys, so let's very quickly go through the last part of this question. I'd really like to be able to get to our finance question for you to take that down. The next part says, given that h of x is equal to the derivative graph of f, where f is a function that is defined in that domain, explain why f has a local minimum. And guys, I'm just going to explain this to you. I'm not going to do the working out, but the reason this would have a local minimum, remember, to find out whether a graph has a local minimum or maximum, you would take the second derivative. So we've got that the first derivative of h of x is 2x minus 3. If I take the second derivative of that, what do I end up with? Just 2. Now 2 is greater than 0. It's a positive value. So since the second derivative is positive, your graph of f must have a minimum value. The other way you can do this is you can look at your graph of h and you can see that it's negative up to the point 3 over 2. And then it becomes positive. And we know that if we have a graph going from a negative gradient to a positive gradient, you have it decreasing, you have it turning, and then you have it increasing. So therefore, you could also say because your derivative goes from a negative to a positive, it's going to have a minimum value, your graph of f. And then lastly, we had to work out the value of the maximum gradient of the tangent to the graph f. Now remember, the graph that you've got drawn here is the gradient of this function f, okay? So therefore, if I want to find the maximum gradient of the tangent to graph f, I need to find the maximum gradient or the maximum value of this graph, h of x. And so we can see, and we've actually already worked it out, that our maximum value for h of x occurs when x is equal to 4. And we saw earlier when we substituted x is equal to 4 into h of x, we got that y had a value of 5. So therefore, the maximum value for your h of x, which will in turn be the maximum value of your tangent f of drawn to the graph f of x, will be 5. All right, so therefore, let's just write this down. We can say that the gradient will be equal to the derivative at the point 4, and we know that the equation for the derivative was given as h of x, so it will be equal to h of 4, and that was equal to a value of 5. So that is your maximum gradient. Very, very quickly, I want you to at least take down the key concepts from our last question for today, which is on finance. And I will go through as much of it as I can with you, but I'm going to give you 2 minutes just to take this down. Okay guys, so one of the best ways to approach financial maths questions is to start by drawing a timeline and marking down all that you can on that timeline. So what you needed to do was take down all the critical values that you would put on your timeline for this question. Okay, let's quickly go through it. So we see that Sebokosi has bought a house. She paid a deposit, quite a big one, 102,000 Rand. It's equivalent to 12% of the selling price. She then obtained a loan to pay the balance of the selling price, and we see that the interest is charged as 9% per annum compounded monthly. First part, determine the selling price of the house. Okay, so for part 1, to work out the selling price, well, we know she paid a deposit, 12% of whatever the value of the house is. So your selling price is going to be your deposit, which was 102,000, divided by 12%, which is 0.12. And that will give you an answer of 850,000 Rand. All right, so that was the original price of this house. Okay. Part 2, and now we're going to quickly put in our timeline and mark off as much information as possible. They tell you the period of the loan is 20 years. She starts repaying 1 month after it was granted, so that's just a normal payment. Calculate her monthly installment. So let's mark down our information here. And this is really how you should be approaching it as well. You have your timeline and you're going to mark off your key information. So we know that in the beginning she pays a deposit of 102,000. So therefore we know the deposit here is paid of 102,000 Rand. She then starts paying from time 1 or month 1 onwards. And we don't know how much she pays. But this continues for 20 years. But remember, your payments are going to be monthly because your compounding is monthly as well. So this is going to go all the way to time 20 times 12. So in total, she's going to make 240 payments. All right. Okay. So they asked us to work out, here they said, work out her monthly installment. So here, remember, when you're working with loans, you're going to use your formula for present value, which is x times 1 minus 1 plus I to the minus n all over I. So guys, you simply plug in what you know here. Be very careful. Your present value is the amount of the loan minus the deposit. Okay, so make sure you don't make a mistake there. You put in the values that you have. Remember, your interest rate was compounded monthly and it was 9%, so we divide by 12. And this is over a period of 240 months. And then we divide by 0.09 over 12. When you do all of that and you'll put that into your calculator and work it out nicely, I want to quickly give you the answer here. You'll get a value of 6,729 Rand and 95 cents. Okay, once you've got that, guys, you'll be able to work out the rest of this question. I want to give you an idea of what your answers will be so that when you do this, you know what to work towards. So for 4.3, how much interest will she pay over the period? Well, all you're going to do there is you're going to take her monthly payment. So it's 6,729.95, and you times it by 240 minus the amount of the loan, and that will give you your total interest that she's going to pay, and that comes out to 867,188. And then finally, calculate the balance of her loan immediately after the 85th installment. There's more than one way to do it. The easiest way to do this is to work out the balance at time 155, because remember, if we're trying to find out, well, how much does she owe from that point onwards, we need to work out what is the present value of the loan at that point in time. So what you're going to do is you'll find the present value at time 155. So you'll use all the information that you have with your monthly payments. You use N as 155 and your interest rate as 9% divided by 12, and you'll work out the balance of her loan immediately after the 85th installment. If you do that, you're going to get an answer of 615,000 509 Rand and 74 cents. So make sure you get all of that information as well. When you do this, you get to those answers as well. Finally, a very quick summary, because I know we are running out of time, is if you have a look, it's easy to forget a memorized solution, much harder to forget a process for finding a solution you have applied several times. So the key here, practice, practice, and then practice some more. Redo your problems from past tests and homework assignments, especially the ones you got wrong or have trouble understanding. And then importantly as well, don't be afraid to ask for help with maths questions, especially your peers, the other guys in your class, or your teacher, or even online you can ask for help as well. Okay, good luck with your exam preparation. Until next time, cheers.